Welcome to the CETEC podcast, your go-to source for everything environmental engineering. Join us as we delve into sustainable industrial practices, exploring topics like wastewater treatment, water purification, solid waste management, air quality control, noise and vibration, environmental impact assessments, and the latest in environmental legislation. Whether you're a seasoned professional, an industry leader, a student, or simply someone eager to make a positive impact, you're in the right place. Together, let's pave the way to a sustainable future, one episode at a time.
Hi, welcome you all back for another episode of our video series which we discuss on environment engineering. So today we are going to discuss another important act of Sri Lankan environment law which is related to the stationary source emission. So this is again list under the National Environment Act of number 47 of 1980, and there's a special act for this purpose which is called as stationary source emission control regulation number 1 of 19. So this act regulates the emission from all the stationary sources, mostly generated from the industries and power generation power plants. So again, the Central Environment Authority is the primary body responsible for monitoring and enforcing this regulation, and they provide the approvals for emission measurements methods and ensure the compliance, and also they facilitate the industrial complexes to go through the compliance to achieve the compliance through guidelines and inspection. So what is these stationary sources? So stationary sources are fixed sites that emits pollutants into the atmosphere, typically from industrial or energy generation activities. So examples for such stationary sources are the thermal power plants and the standby generators, industrial boilers, cement kilns and incinerators, thermic fluid heaters and furnaces. So all these sources contribute to air pollution and release harmful pollutants, affect the public health, ecosystems and climate change as well. If you go from one by one, first let's consider about the thermal power plants. So when it comes to thermal power plants, there are various energy sources are listed. So primarily emission indicators for thermal power plants is such as particulate matter, sulfur dioxide, nitrogen oxides and smoke. And so fuel types for these thermal power plants vary from oil to biomass to coal to natural gas to naphtha to municipal solid waste. So when it comes to the municipal solid waste, other than this particulate matter, sulfur dioxide, nitrogen oxide and smoke, there are other pollutants are also mentioned in the act, such as carbon monoxide, hydrogen chloride, mercury and lead. So in the act, there are different categories are mentioned for these thermal power plants based on their fuel type and the heated output. So for the oil thermal power plants, there are different regulations for different megawatt values or their output. So there are categories for less than 1 megawatt, and between 1 to 3 there's a separate category, and 3 to 25, 25 to 100 and more than 100 megawatts. So there are different categories are mentioned. Similarly, for the biomass also, there are 3 categories, less than 0.5 megawatts, and 0.5 to 3 megawatts and more than 3 megawatts. Again, for the coal, 2 categories, less than 50 megawatts and more than 50 megawatts. Natural gases, again same as coal, less than 50 one category and more than 50 another category. So that is the thermal power plants. Now let's go into the standby generators. So standby generators, there are basically 3 categories of fuel are used: gasoline, diesel or heavy oil. So in this standby generators category also, the act has mentioned the particulate matter, sulfur dioxide, nitrogen oxide and smoke as the key ingredient to measure or control. And for the boilers, again, the fuel types are mentioned as oil, biomass, and coal. And there are two categories. One is the boil or the steam output is less than 2 metric tons per hour is one category, and more than 2 metric tons per hour is another category. And here also they measure the particulate matter, sulfur dioxide, nitrogen oxide, and smoke as the main pollutants with respect to boilers as well. And then the thermic fluid heaters, again oil, biomass, coal are considered as the fuel options. And two categories are mentioned: less than 5000 megajoule per hour and more than 5000 megajoule per hour. Here also the particulate matter, sulfur dioxide, nitrogen oxide, and smoke are the main pollutants. And there's the next category is the incinerator. So incinerators, based on our input, there are three categories. So less incinerators less than 1 metric ton per hour, the combustion capacity is a one category, and another one is more than 1 metric ton per hour, and the other one is any infected waste incinerator. So in here there are few other, like there are more parameters are listed for the incinerators. So other than the sulfur dioxide, nitrogen oxide, particulate matter, and smoke, there are carbon monoxide, hydrogen chloride, mercury, lead, dioxin and furans also mentioned. I hope you can understand the other parameters, but for the dioxin and furans, let's see what are those in a later stage. So then the next one is a cement cleanse. There are different limits for the existing cement cleans prior to this regulation, and after to the date of operation of this regulation there's another set of regulations. Here also the particulate matter, sulfur dioxide, nitrogen oxide, and smoke is the main parameters to be monitored. These are the basic categories of sources they have mentioned in that. Other than this, all the other sources are mentioned under pollutant based standards, and here also they have mentioned two categories: emission limit for combustion sources and non-combustion sources. So in here they have mentioned many parameters under this pollutant based standards. So other than the particulate matter, smoke, nitrogen oxides and sulfur dioxide, they have mentioned the carbon monoxide, total volatile organic compound, chlorine, fluorine, fluoride, hydrogen sulfide, cadmium or its compounds, lead or its compounds, antimony or its compound, zinc or its compound, mercury, and again dioxin and furan is listed here, ammonia, arsenic or its compound, and copper or its compound. So there are many parameters has been listed under this pollutant based standard. And now let's see what is this dioxin and furans, which are mentioned in this previous pollutant based standards as well. So these are the group of chemically related compounds known for their environmental persistence and potential adverse health effects. So they are primarily byproducts of various industrial processes and combustion activities. So these compounds are normally generated through combustion of waste materials, especially those containing chlorine, and certain chemical manufacturing processes such as pesticide production and chlorine bleaching of paper pulp. These dioxin or furans can be generated. So what are the impacts? So these compounds are known for their persistency. So they are classified as persistent organic pollutants, POPs, and these compounds resist environment degradation and lead into accumulation in the food chain, and particularly in animal fats as well. So what are the health effects? So normally health effects are the short-term exposure can lead to the altered liver function and skin diseases, and long-term exposure it will impact our immune system, nerves, and reproductive systems as well. And of course these are carcinogenic. Some compounds of dioxin are classified as human carcinogenic compounds. Then there are another standard where they have mentioned as fugitive dust emission standards. So this fugitive dust emission standards basically means they measure the total suspenders particulate matter TSPM measurement for an industry, and in the act it is mentioned as how we should measure this fugitive dust emission should be the difference between two simultaneous 3-hour total suspended particulate matter measurement carried out on an upwind and downwind basis, so that we have to measure two measurements simultaneously at around the source, upwind and downwind, and so the limit is the difference between these two measurements, or in other words the contribution from the industry shall not be greater than 450 micrograms per meter cube. So measurement location should be within 10 meters of any process equipment or emission source towards the upwind and the downwind. And the wind direction should be most prominent wind direction during the time of measurement. So this is basically to identify how much of fugitive dust is emitted from a source when during the operation. And similar to that, there's another measurement, which is a fugitive non-methane volatile organic compound (NMVOC) emission standards. So here also the act has mentioned as the difference between two simultaneous NMVOC measurements carried out on upwind and the downwind basis from any process area which emits this VOC, or the volatile organic compounds. So they have mentioned that should not be greater than 5 ppm, and the measurement location shall be within 5 meters of the any process equipment or emission area. And again, the wind direction should be the most prominent during the measurement period. So this fugitive non-methane volatile organic compounds are frequently measured in vehicle repair centers where they have this painting activity, and fugitive dust emission standard is normally measured in any dust emitting industry, such as from rice mill to there are various other factories or industries which emit dust, which we can measure under this fugitive dust emission standard. And there's another parameter they have mentioned as fugitive acid mist and ammonia emission standard. So this acid mist and fugitive ammonia mist emission from any process area shall not be greater than 20 milligrams per meter cube. And again, here also they are mentioning that measurement location should be within 5 meters from the downwind from the process area. So here only we have to measure only the downwind, and that location should be within 5 meters. And sampling time period shall be 3 hours, and sampling flow rate should be 1 liters per minute. Then the final standard mentioned in the act is asbestos fiber emission standard. So this ambient asbestos fiber concentration in the process area shall not be greater than 1 fiber per meter cube, and again the measurement location should be within 20 meters downwind from the process area. So the measurement method can be any method approved by the authority shall be used. So when we are measuring these gas compounds of the source, we have to make sure that this concentration of this pollutant should be converted into dry condition first. When we are before comparing with the standard value mentioned at the act, it has to be first we have to remove the moisture content, so that we have to convert it into dry condition first. Then those dry condition should be again converted into standard condition, which means standard pressure and standard temperature. So standard pressure is 760 millimeter of mercury, and standard pressure temperature is 273 Kelvin. So we have to first convert these measurements into dry condition, then we have to convert into the standard condition, because in the act it is mentioned from the standard dry conditions. So we have to convert our normal site measurements into dry condition and again back to the standard condition before comparing the values at the act. And when it comes to the fuel, if you are using any fuel source, based on the fuel type, there are different reference oxygen levels are mentioned in the Act. So those are the measurements and measurement conversions or calculations which we should do before referring this Act. Normally these measurements are most of the time measured using the stack, because these point sources are oftenly connected to a stack, and in the Act they have mentioned a minimum stack height as well. So this minimum stack height of a combustion or point source is dependent on the normally dependent on the height of the tallest building around this stack. So that height in the meters of the tallest building within five height or five stack height of the radius in the point source. Normally we have to take care of the tallest building around surrounding area, and again we have to check the heat output of the point source as well, because that also impact the emission and eventually the stack height. So in any case, the stack height shall not be less than 20 meters if the gross heat output of our source is greater than 0.62 megawatts. And when our source emit sulfur dioxide, normally from the thermal power plants, and it can be any other combustion source. So if it emits sulfur dioxide, the stack height would be considered, stack height should be determined based on the sulfur dioxide concentration, or otherwise we have to use modeling software to determine the stack height. What are the special considerations? So special consideration under this Act would be for the incinerators, temperature and retention time requirement has to be maintained properly, which will control the dioxin and furans. And for the crematoriums and multi-fuel sources, the special regulations are there. For emission from the crematorium shall be controlled by the emission reduction devices incorporated into the stack. And for the incinerators, in order to control this dioxin and furans emission, the temperature has to be maintained around 1000 to 1250 Celsius, and 2 to 3 second retention time has to be there in the secondary chamber. So normally the incinerators are designed in multi-chamber. Basically it should have at least 2 chambers. So in the secondary chamber, the incinerator should have 2 to 3 retention time to burn out these unnecessary harmful gases. Any person shall not emit or discharge any pollutant to atmosphere exceeding this pollutant based limits mentioned in the Act, and any person who fails to comply with the regulation is liable to an offence under the National Environment Act. So why we control this emission? Because it is important to reduce the pollutant that contribute to the respiratory diseases and environment degradation and the global warming as well. So the goal of this standard is to maintain the air quality standard and protect human health and biodiversity and comply with the international environment standards. The challenges of the implementation would be the industries has to invest some money to adapt to these standards, and then the availability of emission control technologies or the technical gaps are also there when we are implementing these challenges, implementing this standard. And in summary, we must emphasize the importance of compliance with this emission standard and the role of the stakeholders of mitigating this air pollution. So through this Act, industries are encouraged to commit to sustainable practices through this Act. So with this, I would like to conclude today's episode as well. So please do subscribe to our channel and comment below about your question and any other matter related to this video. So hope to see you in the next video. Thank you very much.